So what we're going to look at today is using something called trigonometry to find missing sides in right angled triangles. We've just spent a couple of lessons looking at Pythagoras' theorem, and the way you know when to use trigonometry rather than Pythagoras' theorem is that angles are involved. We're going to start slow. We're going to start looking at one type of trigonometry. There are 3 functions you're going to look at over the next week or so, and this one is called sine. Okay. On your calculator, it is abbreviated to sin, S-I-N. Okay, so make sure you can find that on your calculator and you're happy with where it is. Now, sine is a function. That means it's not a number on its own. Sine by itself is not a number. It needs an angle. And that's going to be really important later. So, we can't just have sine. We can have sine of an angle. So, for example, we could have sine of a 24-degree angle. And we would write that sin, and in brackets, 24 degrees. And if you take your calculator and you put in, there we go, you put in sin, sine, and then 24, and then close those brackets off. It's always a good idea to get in the habit of doing that. And you should get 0.4067. Let's round that to 0.41. Now, what I want you to do is to do that on your calculator. If you don't get this answer, then your calculator is in the wrong mode. Now, you'll see here, there is a D highlighted on my calculator. That means that I am measuring angles in degrees, because that currently is the only way we need to measure them. You can measure angles in different types of measurement. They are radians and gradians. We're not going to use either of those, we're going to use degrees. But if your calculator is in, for example, radians mode, and you type in sine 24, you end up with is negative 0.9, blah, blah, blah. Anyway, that's obviously not what we're looking for, because I've just told you this is what we're looking for. So if you've got a number that isn't 0.41 for sine 24, you need to go into the mode of your calculator, or in this type of calculator it's in setup, so you press shift and then mode, which gives you that. And can you see it says deg, rad, gra? We want deg, we want degrees, so type in 3 and it will give you the answer that you want. Much better. If you've got a slightly different calculator and you're not sure how to do it, send me a picture of your calculator. Don't send me a picture like that, because that's just pointless. Send me a picture of like the main calculator part, and I can tell you what buttons you need to press to get the right mode. So once you're happy your calculator's in the right mode, and you're happy that you know where the sine button is, then we're ready to have a go at some questions. So here's my first question. I have a triangle. I know it's a right angled triangle, and I know one angle and one side for my triangle. I am going to use trigonometry, in specifically the sine ratio, to find the missing side x. Now we need to learn some labelling. We already know the hypotenuse. This is the hypotenuse side, 14. I'm going to shorten that to hype. Now, how can we describe the side x? We can't say it's the height, because we could turn this triangle around and then it wouldn't be the height anymore, it might be the base. So we can't just call it the height. It needs to be in relation to something on the triangle. So what do we have on the triangle? We have an angle. How would you describe x compared to this angle? It's opposite. Can you see how it's opposite? Yeah? I like to think if you draw an arrow coming out of 21 degrees, you're going to hit x, which makes x the opposite side. And I'm going to shorten that to op. Now we can use the opposite and the hypotenuse side because they are the ones that interact to make the sine function. So we need to know a formula, and our formula is sine theta. That's just a symbol for an angle, by the way. It's a Greek letter, theta. You don't need to know that, but I'll just put it on there anyway. Equals the opposite side divided by the hypotenuse side. Now that is actually one of the first steps in our working. Our first step is labelling the sides, which we've just done. And our second step is to write out the formula. The formula is really important, and you'll find out why in a bit. Now we've got the formula, let's put in our information. So, the sine stays the same. In the brackets we put our angle, and our angle is 21 degrees. Equals, our opposite is x, so that goes on top of the fraction. And our hypotenuse is 14. That goes on the bottom of the fraction. Now I don't want to know x divided by 14, I just want to know x. So how can I rearrange this so that I've got x on its own? I need to get rid of that 14. It's a division by 14, so we're going to multiply by 14. So that gives me 14 times sine 21 degrees. Now, if this was in a GCSE paper, this would probably get you 2 out of the 3 marks. So even if you've forgotten your calculator, doesn't matter. You've got 2 out of your 3 marks straight away, just by writing down this stage here. We've labelled the sides, we've written the formula, we've put the numbers into the formula, and we've rearranged the formula. That's where we've got to so far. Now the final step is just putting it into our calculator. So take your calculator and you put in the numbers 14 times sine 21, don't forget your bracket on the end, equals 5.01. 5.02 if we round it actually. 5.02. Now let's just check that that's sensible for this triangle. If this side is 14 and that's the hypotenuse, that's the longest side, does it make sense that this side would be 5 centimetres or 5 metres or whatever? Yes, it does. It's sensible. If it was longer than 14, we'd know we've made a mistake. 14 is a hypotenuse after all. But that's a sensible answer for this triangle. So that's the last thing we do. We check it's sensible. Let's have a look at another example. Okay, I'm going to keep that first example on there for you so we can draw the parallels as we're going through. So the first thing I did last time was I labelled the sides. We know that the longest side is the hypotenuse. So 7.2 is hypotenuse. And what would we call x? Well, it's opposite again, isn't it? Think about an arrow coming out of 65 degrees. It's going to hit x. X is the opposite again. Now I know it's written up there. I'm going to write it again because it's good habits. We write the formula out. Sine for an angle equals op over height. And now we put the numbers in. Sine, this time it's 65 degrees. My angle is 65 degrees. Equals the opposite, which is x, divided by the hypotenuse, which is 7.2. Okay, like we do last time, we found out what x was on its own, so we need to remove this division of 7.2. So we're going to have 7.2 times sine 65. That's 2 out of our 3 marks, remember, that stage there. And now we pick up our calculator and we pop that in. And it gives me 6.53, 3 significant figures, 6.53. Again, check, does that make sense with this triangle? Yes, it does. This hypotenuse is still the longest side, and 6.53 is a sensible number to be alongside 7.2. Okay, let's have a look at a third example. Now this example is different. Some of you might be able to see why straight away. Oh, I have a very nice new pencil here. Isn't that nice? A present from Miss Irons for Christmas. Anyway, I've digressed totally. So, same as before, we label the sides. That's always going to be our first step. So, this side is the hypotenuse because it's the longest side. 5 is the opposite because it's opposite the angle 27. So, we write the formula. And then we put the numbers in. Oh my goodness, didn't write this whole formula, going crazy. The opposite is 5. the hypotenuse is x. Now this is where we see really how this is more different than the others, because all the others had x as the numerator of the fraction. This has x as the denominator of the fraction. Now what I'm going to do is, first of all, I'm going to show you the y, I'm going to show you the full method, and then I'm going to show you the quick trick. Okay, but we need the full method first. We want to get x on its own. At the moment, x is on the bottom of a fraction. We don't like it being there, so let's multiply by the bottom of the fraction. Let's multiply by x. That gives me x times sine 27 degrees equals 5. Fair enough, but still hasn't given me x on its own, has it? What's stopping x from being on its own is this. We're timesing by sine 27 degrees. So let's do the inverse. Divide by sine 27 degrees. Which means that x equals 5 divided by sine 27 degrees. There we go. We've now got something we can put into our calculator. Which gives me 11.0. Three significant figures, that is. Does that make sense for this? Yes. It's the hypotenuse. It's supposed to be, excuse me, the longest side, so that does make sense in this case. So like I said, this is the 2 steps that takes us from here to here, but there is a quicker step. Now you look at this fraction here, and think about where x is. X is on the top. And what did we do? We timesed. Look at this fraction. Where is x in this fraction? X is the denominator. And what did we do? We divided. So, my quick trick for you is that if x is on the top of the fraction, we times. If x is the denominator of the fraction, we divide. Top times denominator divide. Okay. So I'm going to do another video with the method so that you can refer to it more quickly. This is quite a long video. I don't want to make it any longer. So I'll do one more video, and that's going to have the method nicely laid out for you, and an example with x on the top, an example with x as a denominator.